Let's look at this problem today, longest repeating character replacement. You can read the problem statement. It basically says that at max you can convert any uppercase character to any other uppercase character k times. So if the number of changes are less than or equal to k, then you have to basically tell the longest substring. So in this case, if you convert either of 2a's or 2b's, because our k is 2, then we get a length of 4. And similarly for another example, if you convert this b here at third position to a, so you get all 4 a's. Alternatively, you can also remove this a present at fourth position to b, so you get 4 b's. Okay, so from the looks of it, we get a little hint of applying sliding window since it involves asking us the longest substring. Substring being a continuous characters in a string. So let's think sliding window. Now let's say you are traversing this, let's take this examples. So initially you are at 0th, you encounter an A, you see you increment A's frequency by 1 and your max frequency at this case is also 1. Now when you encounter B, you increase B frequency by 1 and your max frequency still stays at 1. Then you encounter A again, your max frequency becomes 2 and A's frequency becomes 2, but the total is 3. 3 minus 2 is still less than or equal to k, so you allow this change. And similarly for the last b, your max frequency is still 2 and overall characters are 4, so 4 minus 2 is still less than or equal to 2. That is why our answer is 4. So we don't need to shrink our window. It will get much easier when we code it up, so let's code it up. The standard template for a sliding window is basically to declare your left and right pointer. So your left will be at 0, your right will be at 0 as well. And let's say that the size of string is n. And you need a vector, frequency vector basically to store. And it is also mentioned that all the characters are only uppercase English letters. So we know that there are 26 of it. So initially all of them will be 0. Now we also need a max frequency variable. So max f will be initially equal to 0. Okay. Now we start our traversal. If my right pointer is less than n, then first step I will do is increase my frequency of the current character. So I will do something like mp of s of r minus a, just to keep it within 26 plus plus. Then we will find out our max frequency. Max frequency is equals to max of max f comma this value here. Okay, now we have calculated the max frequencies. What will be the total number of count? Total number of count will be nothing but my r minus l plus 1 minus of this max frequency. So I'll just name it in a variable, let's say change or remaining, anything like that. I'll just stick to change. Change is equals to my r minus l plus 1. This is the total length of my substring which I am considering. Okay, subtracted by this max f. Alright, if this is equal to if while my change when do we shrink our window? When we have exceeded that k. So while my change is greater than k, what I do, I shrink my window. So the way I shrink it is I remove first I decrease the count of my left pointer, then I do L++, but herein our change is dependent on max frequency. Okay, remember that. So I have to calculate the max frequency again, since now it will be changed. So I will initialize it again to 0, and then I will basically traverse my whole vector. My vector is of size 26, so this operation is almost constant, and I will just look for max frequency is equal to max of max frequency and my current, basically my MP of I in this case. Okay, now what is my change again? My change is equal to basically R minus L plus 1 minus max of F. Alright, so we continue doing that until we get out of this loop. And final step is to also have the size. So I will have one answer variable for my actual size, and my actual size will be nothing but my length of substring, which is R minus L plus 1. And at last I increment my R, and in the end we just return answer. Let's see and run it if it runs fine. Okay, okay, perfect. So we are getting a sample test cases passed. Let's discuss the time and space complexity of the solution. So what is the time complexity? If you observe, I am just following the standard sliding window approach, where my R pointer is going from 0 to n, and so can my L pointer. So, and this operation will just say that it's near constant, so I won't really take this into consideration. So my time complexity is nothing but n plus n at max, so basically n. And what is my space complexity? My space complexity, I'm using this 26 map array, and that is all. Rest we have just variables, so we will say that our space complexity is constant. Let's submit this. Bingo.